But what I'm going to be talking about is using structural alignment theory in verb learning research. And I know a lot of people in this group usually study analogy, but others study, how we're going to hear talk about relational similarity in B's, which I'm excited about, and early math. And so here's one more area that we can use this theory in, early verb learning. So let's get started. And I can remind some of you, and then some of you know this well, that verb learning is a really important problem, but it's really difficult. And so to learn a verb, children have to really figure out what package of elements go together to fit that individual verb's meaning. And the package of elements that they need to pay attention to is different for different verbs. So, for example, the child could be hearing eat, drink, talk, or laugh in the same situation. And that verb would be picking out different parts of this event. Maybe they would be hearing don't play with your food too. And that's something that's not happening. So they have to figure out what elements of that event fit an individual verb. And that's a hard problem. Different verbs use different size packages. And it also varies by language. So languages have different kind of patterns that they'll have. So not only do we have to figure out how they learn a verb for one situation or link it in one context, but we have to figure out how they can spontaneously, productively extend it in new situations. And we want them to be able to extend it in the right way. So we know that children might hear eat when they're eating, but how can they know that when they see cats eating that we could also use that verb, or children eating ice cream? We know this is a hard problem because children often have been seen and shown to be very conservative. So when they first learn verbs, they tend to just use the verbs in the way they've been heard. And how do they ever get beyond that? One thing that would really help them in both learning a verb and figuring out how to extend it in the right way is cross-situational learning. So comparing across different situations. So if a child can compare eat, when they hear eat, if they somehow compare their own eating with the dog eating and with watching their sister eat, maybe they could learn something by comparison. There's actually 3 theories of how they might do this that I know of. One is structural alignment, and that's what I've really used in my research. And I'm going to talk about how we could apply this to different events. Another is statistical learning. That's a more brute force theory. And I want to, at times, I want to bring it up in this talk and talk through how and when maybe they're using statistical learning. But I don't think it's very rule governed. The way I see it is it's sort of brute force computing some statistics. And so let's look at that as we go. The third one is hypothesis testing. In that view, when they heard eat for themselves, for them eating, they may make a guess, and then they're going to test that in future instances when they hear the verb eat. So they propose and then test their hypothesis. It's an interesting theory. I haven't seen data, with verb learning, and I'm not going to really focus on it, but I wanted you guys to know it was out there. So I'm going to really focus on structural alignment, but I'm going to bring up statistical learning when I can. So there's really 2 key ideas in structural alignment that are really helpful for verb learning. One is that what they're doing when they compare instances to each other is that they're going to align specific elements from one event to the other. And most of you guys know this theory really well. I just want to walk through a verb example, or an event example, I should say. And so if they're going to compare these events, they would align the truck with the car down here because they're both towing the other object, and they would align the small car with the boat in the second instance. And so they're paying attention to the relations across the 2 and comparing the agent in both and the affected object in both. That's a really great theory for verb learning, because that's what they need to pay attention to learn a new verb. They need to be paying attention to agents, patients, or affected objects, and be able to think about how to compare those structurally. Another, and I'm going to show you how I test some of that in my work. Another key idea in structural alignment is progressive alignment. That's the idea that children and adults maybe learn how to compare and learn how to learn by seeing high similarity examples that are really similar to each other at the beginning, and then more low similarity examples as it goes on. So this experience with real simple comparisons or similar comparisons helps them learn how to compare more varied examples. And I'll show you how I tested that for that. But if we think about statistical learning for a second, remember, statistical learning is about co-occurrences. You're looking for a co-occurrence between an event and a verb that they're hearing. And here's a study from Cindy Fisher that studied that and asked, could children hear verbs like pimming and nading? Could they pay attention to what is repeated? So in the second trial, only one of these actions is repeated another time, this moving action, and they only hear one of the two verbs again, pimming. Can they follow that co-occurrence over trials and learn the verb pimming? And the answer was yes, if it's a simple event like this, which is a body movement, and no, if it's a more complex event or it's harder, need a little bit older or a little bit more savvy child to be able to do it. If there's an event where the person's holding an instrument and doing something else, it's a more complex event. That'll become important later also. So the interesting thing about statistical learning is when you see dissimilarities, it's kind of unclear what you would do. I think you ignore it when it doesn't co-occur. When it's dissimilar, you discard or ignore. Whereas in structural alignment, when there's dissimilarities, things that don't align, that could tell you that this verb is a more general verb, and it could actually expand your understanding of that verb's scope. And so in my mind, these theories are working differently with dissimilarities. I would love to hear your take on that though too. So here's some prior evidence for statistical learning. So if we think about those things as background, in the first study, I wanted to ask, how do they extend a verb? So we know that we can help them learn a verb, but how can we test beyond that and see how they might extend a verb to new situations or new events? Like that example where they learn eat and then they see cats eating and they know that they can say eat in that instance. Well, one of the earliest categories that they seem to be able to extend verbs to is the agent. So they seem pretty good at extending a verb across different agents, which is good because we don't have proper verbs. We don't have verbs that only have to do with one agent. So because I already knew that we had all this prior evidence, here's 4 prior studies showing that they can extend to agents, it was surprising when there was a study by Mandy McGuire and her colleagues showing that 2.5 to 3-year-olds were having trouble when they were learning a verb, and it had 4 different agents. That was kind of surprising to me. And I started to think, I wonder why multiple agents were giving them trouble in that study. And so I'm going to start with that first study and ask, does variability, that seeing those 4 or 3 agents, actually hurt verb learning? Does it help verb learning? Let's look at this further. So this study we did in San Antonio, which is where I'm at. And I also worked with Jay Pak, and she went to Chengdu, China, and Seoul, Korea, and collected data there. She also had a student who was a bilingual English Mandarin speaker, and she collected data in Singapore. And so we were able to collect data across these different settings, different languages. And we asked a pretty simple question, which was, do children learn verbs better when they see one actor versus 3 actors or agents. And then does it matter how complex the event is? Remember, Fisher's study, the events are pretty simple. They're body movements and the one that they do the best at. So I started thinking maybe the complexity of the event is important. So we're going to just do a pointing study to video. I'm going to show you stills, but they're all video events. And so we have this series of events where an action is happening. We have a 1-actor condition for half the kids and a 3-actor condition for the other half. And so you can see it's just a simple body movement, and children see one person do it, or they see 3 different people do it. And then at test, they have to point, and of course, one is right, one is wrong. So we're going to compare how they do on these simple events to a more complex event. So they saw 2 simple events. That was just one example. And then they also saw 2 complex events. Here, this person's using a hammer. It has a magnet on it, and they're going to pick up something from the table with their magnet. And so they see one person do it before test, or they see 3 people do it. Notice that the person's different at test. And what we found was, kind of surprisingly, across languages, we found the same pattern. So we didn't find differences in different language groups. What we found was that when they got the same agent, that one agent, and it was a simple event, they could do both the simple and the complex event if it was only one agent. So one agent did work well for both types of events. But when there were 3 different agents, now they could do the simple event, which is a little bit slightly different from what McGuire had shown, but I'll explain that in a minute. Not too different, but when they saw the complex event, the different agent really had a cost. So remember I said they had a harder time when there were 4 agents. They did have a harder time, but they still succeeded in McGuire's task. So that's why I say it's not that different. So in our study, both 1 agent and 3 agents, they succeeded. They also had succeeded in the McGuire task, but we didn't find any benefit for same agent for that kind of event either. Whereas in different agent, there was a cost when it was this complex event. That's kind of interesting. That suggests that variability is really hard for children. So children could extend the verbs in the 1 agent condition. Variability didn't really help performance or hurt performance when they got a simple event. But with the complex events, children across languages could only do the 1 agent condition. So variability hurt performance. So the next thing, so it was kind of surprising that variability impacts their ability to compare events, even when they're verb-friendly languages that you're testing in. And in the 2 theories, variability could affect alignability, so it could make the events harder to align with each other. And in statistical learning, it could make computing those statistics more difficult. Kind of makes sense, variability would be difficult. So how do we help children, or how do they learn how to process variability? They don't get stuck there in development. They can learn verbs. We just have to figure out how they're doing it. So how do they learn how to learn verbs? How do they learn how to process events that are more variable? Well, now we can use progressive alignment from structural alignment theory and test whether similar examples help. So does it help them to see some similar events first and then see the more varied ones? I showed you a prior study with learning a part term, where they had to learn a belly button part. So now let's test it with events. Similar examples would help because it helps you notice that you could compare events to each other because they look similar. And also it should be easier, so you should be more successful. Also, there was prior work from Mitsumi and Mai's lab showing that progressive alignment helped children learn verbs, but they only had they were looking at the progressive alignment between learning and test, and I wanted to look at progressive alignment during a learning phase. And so I wanted to add multiple events and also see if I could use an eye tracker to figure out more about where they were looking during learning. So in this study, we have 2, 3, and 4-year-olds, which is going to be pretty standard across all my studies. We're going to have 2 conditions. One, a progressive alignment condition where they get similar than varied events, and I'll show you an example in a minute, and one all far where they just get to see varied events through the entire learning phase. We're going to have a dependent variable, which is going to be how long they look at different elements within the learning phase. If they're structurally aligning, it's really interesting to think about them looking at the agent and looking at the tool, looking at the affected object. So we need to understand that looking better, and then they're going to point at test as they do. And here's what our setup sort of looks like. They sit in this chair. We have the eye tracker here, down here. This is our older model. We have a newer model too that sits right on the screen, but it kind of gives you an example. So in our studies, we have to calibrate the tracker. There's a warm up to get them used to pointing. Then there's a learning phase, a test phase, and we always show it more than one verb. And so in this study, in the progressive alignment condition, because we were using video, we were able to show them one and the other at the same time. They came on one at a time, and then they came on together to try to help them compare them to each other. So in progressive alignment, similar first, you can see these are really similar to each other. They're the same shape, they're the same size, and then they come to more varied ones. Whereas in the all far, we started with the same kind of event, but now the second one is still pretty different, and they see the last 2 events. And so what we're going to do is we're going to compare tracking not to the first 2 events, which are different across the trials. Of course, their looking is going to be different, but we're going to compare their looking to the second pair of events where they're seeing the same thing in both conditions. What we're asking is, does this experience affect their looking in the second pair when they see the same events? And here's how we drew the AOIs. Again, this was one of our first studies using the tracker. And so we drew them really precisely. And then we found out later that it's better that the tracker's not, or actually our eye movements are not as precise as we think. And so we actually need more room around objects because our eyes can look around the object too. So I'll show you a different study later where we have more gaps in between the AOIs, but this one, we published it. We were trying to be really precise so we could still say something about it. So after they did the learning phase, here's test, and we just asked them to point to the one that matches. And of course, one is going to kind of look like the one they've seen. The other one has the same objects, but it's different action. And then we tried to create one that was like a little bit more difficult, where the distractors kind of hear natural but wrong, and this one's a little unnatural but right, just to see how far can they extend this verb. What we found in the looking part is that 2.5-year-olds, only in the progressive alignment condition, started looking more to the agent than they did in the all far condition. So that's kind of interesting. That's good. They're looking more at the person doing the action after that similar first experience. They also looked longer at the affected object, only in the progressive alignment condition. So they're looking at some really important parts of the event, which is who's doing it and what tool is that person using. Or actually, I shouldn't say tool. What is being affected? So looking at the agent and the result. Maybe the tool is just too small. And so what we found in this study was that great looking that they were doing
didn't lead to them being successful at that age. So we found a benefit for progressive alignment in looking, but it didn't in itself lead to success. However, 3.5-year-olds did well in the progressive alignment condition only, although they didn't show differences in looking. So sort of like children at both 2.5 and 3.5 benefited from progressive alignment, but in different ways. Now these 3.5-year-olds can only extend the verb in the progressive alignment condition. They can't do it when it's all varied, all far, all different events. They're not able to compare those at 3.5. So the looking data showed a benefit for progressive alignment for the youngest age. The test data showed a benefit for progressive alignment in the 3.5-year-olds. Both of them together show that progressive alignment helps children learn verbs, that it may help them learn how to compare, and comparing seems to help them learn the verb. So in the third study, and this is one we're doing right now with Mitsumi and her 2 students, we're asking, can we extend progressive alignment, this kind of study, to other languages? And we're working on Japanese. So Mitsumi had a couple studies showing that were really, really exciting. And they were showing that children younger than 5 can have trouble learning and extending verbs. She included English, Japanese, and Chinese. So these are great papers in child development. And they were really interesting in showing that it was difficult to learn a verb. So what I thought when I was reading these papers is, I wonder if progressive alignment could come in and help. And if we adapted this task and included it, if we could show some better verb learning in that case. I also wondered if a test trial could help. So in the original papers, after the child sees one event, they're shown a test trial, and it's very controlled in that the object from the first event is moved in a different way on one side of the screen. So that would be the wrong answer for the verb learning child, because, and I should say they're learning nouns and verbs in these kinds of studies, and some are learning nouns and some are learning verbs, which is also a great part of the studies. But in the test trial, after they see a single event, that object is shown on one side of the screen, moved in a different way. And that would be the right answer for a noun child, but the wrong answer for a verb child. And I just thought, I wonder if children get caught up in the object, and when they're learning a verb, they're just cannot resist pointing to this object they've seen before, even though it's being moved in the wrong way. And so let's have a new test trial, all new objects, and see if they can do better. And we're going to examine Japanese-speaking children and English-speaking children. And Mitsumi is lovely and ran with her students, ran a bunch of Japanese-speaking children. Actually, they're ahead of us. They're actually doing better at collecting data right now. So in this study, we have 60 children at our 3 ages, 2, 3, and 4, from Tokyo. Run in Tokyo with a Japanese speaking research assistant. And then we're getting close to getting our 60 in each age in San Antonio. It's taking us a little bit longer, but we're going to catch up. And we have 2 conditions, just like we did before. We have the progressive alignment, and then we have all far, all varied, same thing. We're going to have 2 kinds of test trials. One is going to be, I'm calling easier because it has all new objects. And I'm worried that that one object was distracting. So the easier one I see is let's start with all new objects. And then the other one is the same one from the prior work, where it has only one object. So what's new in this study is, instead of just seeing one event and then test, they see 3 events, and then they get these 2 test trials. And here are the Japanese verbs we used. And so here's the warm up, and they get to practice pointing. Mitsumi also designed this cool learning or warm up phase where they actually hear a novel verb, and they get to then practice pointing to that same event again, just to kind of learn the game. And then here are our trials. And she talked about this earlier this year, so you've already seen this stimuli. But just to help you see the varied part, so notice the objects are really different on the all varied side, and on the progressive alignment are similar first. The objects are more similar to each other. They're all small, they're all bendable, they're similar in shape. Not exactly the same, but there's more similar. So they hear these sentences, or they hear the word in Japanese. And then we get test. And there's the 2 test trials, and it's counterbalanced. So half the kids see it one direction, half the kids see it the other, in the other order, I mean. And so here's the more difficult one because they had seen this object before, this red object. And then here's the easier one. And we can see if they can extend the verb. And here's the Japanese data. And what we find is that 2-year-olds fail, so they have trouble. 3-year-olds can do it when it's progressive alignment, and they can do both kinds of test trials. They can't do it when without the progressive alignment experience, they're at chance. 4-year-olds can do it all. And then if we look at the English-speaking children so far, our 2-year-olds are also failing. But the 3-year-olds, just like the Japanese children, they're benefiting from progressive alignment. So they can do both test trials when they get progressive alignment. For the all varied, they can only do the easy test trial. They can't do the difficult test trial. So also interesting. We'll see if that holds up as we finish the data set, but that's also interesting. Maybe they're beginning to be able to do some variability. But really, mostly the kids are similar. So across these 2 language groups, they're similar in that both the 2.5-year-olds fail and the 4.5-year-olds can do it. And the 3.5-year-olds in both language groups are benefiting from progressive alignment. So progressive alignment can help children learn verbs and extend verbs really by 3.5 in both languages. So what about this idea in structural alignment? The idea that you're actually aligning by paying attention to specific elements. So you're aligning the agent in one event to the agent in the other event. Here, maybe you're aligning this child with their sister. And then you're aligning the fork with chopsticks and the food with the food and the plate with the bowl. What about that? How could we show that? And how could we show that using an eye tracker? Well, I thought, what if we change only one element across events? It'll be different in different conditions, which element we choose. And we see with the tracker if they notice that change. If they notice that something's changing, they should adjust their attention to that changing element. And I think they should look longer at it because that's the thing that's changing. So let's see if we can use the tracker and see if we can see that. So in this study, we had 2.5 and 3.5-year-olds, just as usual. But we tested 3 conditions. One where we changed that tool across 3 events. One where we changed the affected object, the thing the tool affected across the 3 events, and a control with no change. And we're going to look during learning, we're going to see, does their looking change? Do they adjust their looking as the trials go on? So as they go from trial 1 to trial 2 to trial 3, do they adjust their looking to that changing element? And then can they learn it at test? Can they extend it test? So we have the same beginning, calibration, there's a warm up, learning, test, repeat. Here's what the learning phase looks like in the 3 conditions though. So we have control. So remember, it's a dynamic event. You stick out your spatula and you flip the ladybug over. We have instrument or tool change. And so we're going to flip the ladybug over with 3 different tools. And then we have affected object change. We're going to flip over something else with the spatula. So we're going to flip 3 different things while they hear these novel verbs. In this case, it's lorse. So here's where we drew the AOIs and we added more separation between the different AOIs. But we drew the agent, the tool, and the affected object. And really, it's just we're going to look at change in tool and change in affected object. So here's what the looking looks like during learning. I'm plotting tool on the Y because we want to keep that consistent. So we're going to use 1 dV. How much do they look at the tool? And I'm plotting X on the trials on the X-axis. So how do they do from the first trial to the 3rd? And let's look at tool change first. Why not? That's fun. So the tool is changing on each trial, and we can see that their looking is increasing over trials. And the asterisk means that was significant. So they increased their looking to the changing tool as the trials went on. Cool. They might be aligning those tools. That's what I wanted to see, if I could find data for. Also, when the affected object is changing, they're decreasing their looking to the tool. So they're decreasing their looking to this thing that is not changing. And that means that they're looking more at the affected object, the way that these proportions are, it's looking to tool divided by looking to everything else. And so they're decreasing their looking to the non-changing tool. Again, to me, that suggests they're noticing that tool isn't changing, or they're noticing the affected object is changing. And then control, they just get bored over trials and they look less at the tool because it's not changing, nothing's happening. Again, they might be looking at the tool though, trial to trial. That's what I wanted to see. So then at test, here's our test trials, and they get 2 chances. Here, there's not one that's easier or one that's more difficult. They're just 2 different ways of showing the event. One where we flip it, and we have different distractors. Can they do it? And here's what we found, that the 2.5-year-olds could learn and extend the verbs, but only in the tool change condition. So when that tool was changing and they were looking longer at it, then they were successful. They didn't do as well in the affected object condition. So it wasn't that all variability was helpful or hurtful. It was that the tool was helpful. 3.5-year-olds could extend them all. Well, why would tools be especially helpful? Because tools are more important to verbs. So verbs are more likely to include a tool like staple. You think of stapler, cut. You think of either a knife or scissors. Their tools are more important to verb meaning than the thing that's receiving the action. It's less important to a verb's meaning. That could be what's going on with these youngest kids. Maybe they're noticing that. And then, of course, what we can ask is, but everyone wants to know from eye tracking, is it any helpful to know where they're looking? Can you predict anything from that? If you can watch what they're looking during learning, can you make a prediction? And my answer is going to be sort of. And so we used hierarchical regression, and there were some predictions so that more looking to the tool, if you're in the when you're looking a lot at the tool, but the object is changing, then you're going to do worse in that affected object condition. So you're looking at the wrong thing because the object is changing, but you're looking at the tool. That kind of makes sense. And then watching that affected object change was also worse. So watching an affected object change is not going to help you learn the verb. Again, verbs don't really care about that. And so it's drawing their attention away from the tools, which could be more helpful. So anyway, recap. And just to go to the main idea. Well, okay, recap. In terms of the looking data, I like thinking this shows they're looking at specific objects from trial to trial. I think there's some evidence of that here. They do seem to adjust their looking as the trials go on to the tool, which is cool. Also, we can see that they can extend the verbs under some conditions, especially if the tool is changing. Does it predict tests? Sort of, not dramatically, not in a great way. So I think the jury's still out on, does eye tracking really buy you a lot? I don't know. In terms of predicting what'll happen later, I'm not sure. Okay, let's move on and just go to a couple more ideas. And so let me just remind you that children are learning verbs not in the lab. And so when you look at their lives, we can't just focus on the 3 instances where they hear eat, because those instances of that they hear eat, one might be breakfast, one might be snack, and one might be dinner. And in between, they're playing and they're going to the grocery store, and a lot of other things are happening. So how are they learning verbs when there's these other distracting events around them? How do they know how to ignore verbs? Can they detect when they should ignore verbs? Was my question. In structural alignment, a cue to ignore these events and not compare these events with eat. One cue is you don't hear eat. So I'll talk about that. Yes, that's true. You don't hear eat. But a second cue is that these are very low alignable. So play is not alignable with eat, with an eating event. So maybe the alignability of the event could also help them realize these are distractor events. I shouldn't be comparing them. So we wanted to test the impact of interleaved distractors. We wanted to create some videos that were more naturalistic, that happen in the real world, that had distractors in them. And in structural alignment, we hypothesized that they should discard those distractor events because they're low alignable. In statistical learning, they would need to detect them somehow. And I'm not sure how they would do that, but maybe you guys have ideas, but they would need to detect them. So we don't want them computing statistics. Maybe it would be listening to the verbs. Maybe that would be enough. But let's see what happens. And so we have 2.5 and 3.5-year-olds. And we designed 3 different conditions. So in this study, they're going to see 5 events. In all my other studies, they're really seeing only 3. So in these 5 events, 2 of them are going to be distractors. 3 of them are going to be targets. So we had a condition where the distractor event was first. Then there's 2 targets, distractor, target. There was a condition where the target was first, and there was an alternating condition. And actually, that was Dedry's idea. When I was talking to her about this, she was like, well, did you try alternating? So I added that. Notice in all of these, they all have 3 target events and 2 distractors. We also ran 2 other conditions, a salience control and a target. In salience control,
We just showed them test trials at a point. In target only, they just saw one event and then they saw test. So we'll see how they did on that. They're going to point at test, and we filmed these events in a kitchen and in a park. And we filmed really 4 events, and we counterbalanced it all, so it's not about any particular set. So here, there's a warm-up just like usual. Can you point to the rolling fire truck? It's easy. And then here, you might have to get close to your screen to see what she's doing, but she's in a park, and here's distractor first. So she's just, sorry, I'm gonna have to get a drink. She's just twirling it with her finger. Then she's gonna do the target event, which is pressing down on it and picking it up with your hand. It's a novel event. She's going to repeat it, and then she's going to do another distractor event, picking up a leaf with her hand, and then she's going to do a target. So there are going to be 5 events. They're all dynamic, but there is a black screen in between each one. So just watch, it comes on, it goes off. All right, and here we are at test. Can they get it right at test? So can they ignore those distracting events? And does the order matter? What we found was children as young as 2.5 could ignore that. So they did well. They could learn the verb and ignore the distracting events. But of course, they get better with age, or, they usually do. And so 3.5s were both successful and better than 2.5-year-olds. But collapsing across age, if we look at this affective condition, we can see that it didn't matter which order those 5 events were in. They could succeed in all of those. So they were doing well, no matter how the target and distractors were shown. Here's the target control. So they weren't learning the verb without comparisons. Again, that's great for structural alignment. You need more than one event. And salience control, they didn't just pick it. They didn't just pick a test trial because they thought that one was cool. And there's a difference between these 2 conditions. I don't think that's that important. What I think it's important is they can learn the verb across these 5 events, even as young as 2.5. And that's consistent with theory because those events that are linked to the verb are the most alignable also. So they could learn the verb as long as they saw multiple events. They failed when they only saw a single event or only saw test. The next question, and we're almost through, is to ask, what if events were flowing into each other and there were distractor parts of events? So when they're seeing the doggy eat and hearing eat, before that, they've seen this event where mom pours the food into the bowl. The doggy comes over and starts eating, and then doggy sits down and smiles at them. Can they figure out, how do they figure out that eat goes with the middle event? How do they do that? How do they parse out these sub-events that aren't relevant? That's what we wanted to test next. Can they do that, and can they ignore distractor parts of events? And so in this case, we added 4.5-year-olds because this is a harder task. We have age, and then we ran 2 conditions. One is distractor first. So the distractor is going to flow into the target, kind of like mom pouring the food in the bowl, then the doggy eating. Distractor last, the doggy eats and then sits down, kind of like that one. The distractor is going to be last. We'll see if that makes a difference. Here's the actual stimuli. And so it's in a kitchen and a park. And so here she's twirling around this pole in the playground, and then she holds out her hand. She's got something in her hand. And we're going to see if they can, over trials, can they compare? Oh, of course. So the distractors got to change across trials. So you can see here she's kind of skipping along, then she's twirling, then she's climbing up. So there's got to be different distractors, otherwise it wouldn't be possible to figure this out. And then she does the same novel action. And so can they, again, use alignability to realize, and the verb, to realize that snarf has to do with this novel action. And here we have it test. So can they get it right? It would be on the right side and then the left side. And what we found is that at 2.5, no, this is now too hard. Having events flow into each other is really difficult. So they fail. But by 3.5, they can do it. They can do it. They can parse events and learn a verb, extend it at test, ignore distracting parts of events. And there is no difference between distractor first, distractor last. It really didn't matter. So if we look at development, by 2.5, they can ignore whole events that are distractors, but can't parse them. Across both studies, 3.5-year-olds could ignore and parse. And of course, 4.5s can do it all. And alignability is one cue that they can use to ignore events that are irrelevant. Our last one is to see if children's visual attention is affected. So we took that naturalistic stimuli, well, we've simplified it a little bit. And we wanted to see if children use the eye tracker and see if they can visually attend differently when there was a target or a distractor. And we predicted that maybe if it's a target event, they should focus on the action, on the hands, because what the person's doing is the most important. But when it's a distractor event, they could maybe focus on the face or the head. We could kind of at least see if they look differently to target versus distractor events. Okay, so we have 2, 3, and 4-year-olds, and we have these AOIs, the head or the hands. That's one part that's new. We have the same procedure, but we simplified the background. Because we're going to use an eye tracker now, we didn't want that cluttered background. And so we just refilmed all our kitchen and park scenes with just a plain background. And so here she's doing the same thing. The just 2 distractors are different. And we're going to see if they look at the head or the hands, and if they look differently when it's a target event or a distractor event. So here's how we drew the AOIs. Now we're not worried at all about getting all the contours of her body. We just have 2 AOIs, head and hands. And here's the kind of a better setup here, our more modern eye tracker, or more recent one that clips on the screen. Here's the webcam. This is a publicity photo, so it's not set up perfectly. They have the old one in here, but anyway, that kind of gives you an idea. And they're going to point at test. And so what we found in looking, what we could do is we could look at the first event they saw, and then the third or last event that they saw. And so what we're going to look at first is the target events, and notice looking to the head or the face decreased as they kept seeing those events repeated. From the first to the third event, they looked less at the head or the face. whereas looking to the hands increased. So that's really interesting. They're looking more as the trials go on, and they're hearing that verb repeated, and they're seeing these alignable events. They're looking more at the hands as they go on. I mean, overall, they look more at the hands than the face too. The hands are moving, but this increase is what I'm interested in, is how is their attention changing as the trials go on, and looking to the hands is increasing. For distractor events, though, they're looking to the head or the face doesn't change. They maintain that over trials. So they keep looking at the head and the face, and they decrease their looking to the hands. They're looking less at the action as these distractor events go on. And that would actually help them learn the verb, because we don't want them distracted by irrelevant events. So if they can turn their attention away from those actions, that will help. And so here's how it looks just on one screen. How am I doing on time? I'm almost done. Okay, and so they're doing okay. I hope you can see that these are different patterns, right? Especially with the hands. One's increasing, one's decreasing. So that's really neat. They're looking differently at target events versus distractor events. In terms of pointing, in this study, they were able to extend the verb in all ages, and our main developmental change was between 3 and 4. All right, so they're noticing when events are distracting and visually examining them differently, and the way they're inspecting the events fits predictions. It fits what would work. So we need more verb studies that show irrelevant, distracting events, because that's really what they're seeing in the real world. So to sum up, I'm sure you guys are all relieved. I have survived the talk, and you have too. Okay, so what have we learned, or what can we see? We can say children as young as 2.5 can learn and can extend new verbs. They can have trouble when events are variable and when events are complex. But what can help them in that case is getting progressive alignment experience. So seeing similar examples first can help them learn how to compare. And we're showing that's true in English and in Japanese. Looking patterns also show that 2.5 and 3.5-year-olds track changes across individual elements. For example, tools or affected objects, heads and hands. They're looking at individual parts of events. And 2.5-year-olds can ignore whole distractor events. By 3.5, children can ignore distracting sub-events as well. They look differently to events linked to a new verb than events not linked to a verb. So are all these results more consistent with structural alignment than statistical learning? Well, yes, they're more consistent with structural alignment because I had that theory in mind when I designed all these experiments. And so they are consistent with it. Could statistical learning explain these findings? Maybe, I don't know. I don't find it as compelling because it's kind of more brute force, and I don't know what it can tell us about how children compare other than just computing statistics. So that's where I'm not sure how to use it. Could they be using both? Maybe they're computing statistics and also aligning. You know, I think we like to pit theories against each other, but they don't have to be pitted against each other. Sometimes it could be both. And just to give you a preview of things that I'm doing right now in my lab, I'm looking across delays. So, you know, what if there are delays between events that are compared, looking at how children remember events. If you're talking about comparing across delays, then we need to know how well they remember events from time 1 to time 2. we're looking at how children compare or learn from sentences, and that's with Laura LaCosta, and looking at the effective context. So what about context? Did it matter that it was a kitchen in a park? If you see something in a kitchen over and over, does that help you compare because you're in the kitchen? That's what we're working on. And then finally, I guess a related question, but a verb learning question is, when do they go beyond these learning verbs one at a time and have a more networked sense of verbs or semantic network? All right, the end. Thank you very much.